hope that at least with today's presentation, if you have not had a chance to look at what vector search is or how you can actually leverage AI on edge and mobile, I hope that this presentation will help you solve all those doubts or queries that you might have been having in your mind. So just quick introduction about myself. I'm Shivay. I'm a developer evangelist at Couchbase. I'm also a TensorFlow.js SIG and working group lead. And I've also been a gold source code mentor for a lot of different open source tooling such as TensorFlow and Kubeflow. And you can follow me on X, on Twitter @howdevelop. And if you have any questions after today's session, I'll be more than happy to answer any questions. Now, we're truly living in an era where everything that we're doing is getting redefined by using AI. So whether we are interacting on a day-to-day with ChatGPT, or you're leveraging any sort of a tool, whether it's like WhatsApp or you're using Google Meet or Google Chats or a suite of different Microsoft tools, right? Or even open source tools, we are seeing AI integration everywhere, and especially like large language model integrations. Every day we see new models coming up. Llama 3 got released, 5.3 from Microsoft. So you're seeing both proprietary and open source large language models getting out every day. So of course, when it comes to being able to see that how we are interacting with these tools on a day-to-day basis, a lot of them are also contextually proactive as well. That means that based on whatever input that you give to them, they will be able to respond to you in a very humanized form. And they are also extremely hyper-personalized based on your user context. They are able to answer you. So there are a lot of different tools that are also coming up that help with productivity. For example, whatever you're doing right now in your entire day-to-day activity, they will keep a track of what you're doing, and they'll be able to answer you any queries based on what you have done throughout the entire day. So we are seeing a true innovation in this entire space. And of course, when we come to understand the entire computing shift, right? Of course, we started off with the client server applications with these huge servers back in 1990s. Then we saw the boom of web applications in the early 2000s. And of course, in the 2010s, we saw how iOS and Android really took over the entire world with the smartphone era. And we have seen a really nice applications of AI throughout these. So you can really run powerful AI models on servers with GPUs. You can also truly run AI models on the web with the help of TensorFlow.js. And also you have now dedicated smartphones that are coming with chipsets that are able to run AI models. So that means that now AI is not just being powered on powerful GPUs. And that's a lot of the misconception that we have these days, that for AI, you need really powerful GPUs. Yes, for running larger models, you need that. But of course, we are seeing so many AI applications on edge and on mobile devices that we are really making a lot of advancements by not only fine-tuning these models, but also just creating models that are sufficient enough to run on edge and mobile devices, because today we are shipping hardware on mobile and on edge that can actually support running these models. And while if you're not able to run these models locally, you can always leverage cloud-based AI models that you can just make a simple API, RESTful API call and call them, right? So that's what we are just seeing, this huge rise of AI agents being powered by large language models coming into the foray. And of course, if we kind of look at the entire AI landscape for developers, you'll see a lot of influx of LLMs, embeddings. And today we are going to be talking about vector search, which is one such category that has completely taken over. And we'll be also understanding some of the use cases when it comes to vector search and how is it relevant for Gen AI applications or generative AI applications. So this the first thing that I'd like to kind of cover is, first of all, what exactly is the vector, right? So let's take a very basic example. Now, something like a simple latitude longitude, which is a combination of two values, right? This is the lat long for Paris. Now, if we take probably another example, 124, 237, 246, this is an RGB value for light blue color, right? So what are these? These are simple arrays with with numerical values. Now let's take a look at something more complex. Here you have this really long array that contains multiple values. These are decimal or floating point numbers. And this is essentially a GPT value for Luke Skywalker joins a Jedi Knight and a Wookiee. So, I mean, this is like reference from Star Wars. But what you see is essentially this long array is nothing but a semantic representation of the data. And vectors are nothing, or especially vectors in the context of vector search, are nothing but essentially these long arrays or numerical values that essentially represent features of something. So for example, if I take an example of an apple is a fruit, so you can define the features as it being a fruit, so being the type, and the color being red. So you could technically represent this information in this long array format, and these values that you see are just representing those real life features of your data, right? So if we take a look at another example, and I'll probably come back to this vector search in a bit, but primarily what you're seeing is that now as you're storing all of these data in this format of these vectors, the next question is that, okay, like we spoke about vectors, but what about vector search? So vector search is nothing but it's essentially now taking your bunch of vectors. So you're basically storing all these vectors inside of your database, and these vectors, as I mentioned, are representing your real world features of your data. And then now what you do is that you'll take a new input from the user that will be generated, and you'll again convert them into this vector format. And now you'll basically compare that user input from the set of inputs that are already present inside of your database. And what you're doing is that you're doing semantic similarity to find vectors that are closest to each other. And when the vectors are closest to each other, that in real life means that the features that are these vectors representing, that means that those features are also similar. So I'll also give a example over here in the future slides, but just think that now if I upload an image of, like, let's say an apple, and I also upload an image of something like a Ferrari car, both of them will get converted into the respective vectors. And now when I do the vector similarity search in this Cartesian plane, the two vectors that will be similar to each other will be very close to each other in this diagram, will basically represent characteristics or features that are also similar in real life. So now when you do a search, it's not just simply that you're searching for a key term. You can actually search for things that are similar in their features as well. So that's the basic context behind how vector search actually works. And here we are using a machine learning algorithm known as KNN, which is a K nearest neighbors. And of course, like, the use cases are profound. You can use it for content generation. You can use it for advanced semantic search. So just imagine that you're on Amazon.com. You find a really cool T-shirt. For example, you really love the T-shirt that I'm wearing, and you just click a picture of this T-shirt and you upload it on Amazon, and it will find the nearest, searchable images. For example, images that are from Nike or black-colored polo T-shirts that are nearest to you. So based on that relevance of the search that you make, you'll be able to find those results. And here's like another example. So let's say that you upload a bunch of images related to tennis, right? So you upload images related to the different US Open or French Open, then you upload images containing images of, for example, the tennis balls, rackets, and also like textual data with very popular, tennis players. And all of these will now get loaded into an image embedding model, which will basically generate these embeddings. Or when I say embeddings, they are similar to vectors. So basically embeddings is the same thing as vectors. So if you get confused, they are pretty much the same. So you're storing these vectors that again have the features of this data. Now let's say you're making a search query, search for French Open. Now since these vectors are semantically related to each other, you will be able to find data not just for French Open, which is basically this image right over here, but you'll also be able to find data that's relevant to it. That means that Novak, who is one of the greatest tennis players, has won a bunch of French Open, or probably Rafael Nadal. They'll be able to actually come up in the search results because they are semantically related to each other. And that's where this vector search really overshines as compared to a standard search that will just search for the query that you're searching for, right? And so you basically search for French Open, and then you get the nearest neighbor results, and you get results of all these similar images based on the query that you're sending in. And this is kind of the reference architecture, something just to kind of recap what we have covered, that you send in a bunch of raw documents, use something like an OpenAI embedding or any other open source embedding model that then gets stored inside of a vector database, and then you're able to make a prompt, and based on those prompts, you're able to get relevant search results. And of course, for those folks who come from a traditional search background, what's the difference between a full text search and a vector search? So traditionally, a full text search would mean that if, for example, I'm searching for Nike t-shirt on Amazon, so it will specifically search for those particular documents that have the Nike t-shirt, right? It will just be simple text-based search where you're querying your data and comparing, and you're finding what is the most common or the relevant search that exists in our database. But with vector search, I see that now you also add that semantic context, and you're able to find a lot of relevant data that might not fit directly as like, search for term by term. So that's what the benefit that you get with the vector search. Now let's take a look at how Couchbase is kind of redefining vector search as well. So just for those folks who might not know what Couchbase is a distributed NoSQL database, and that essentially similar to other type of NoSQL databases, it stores data in an objects form, but it can also do a lot of operations that are traditionally there in a SQL database, such as being able to write joins or actually make queries like SQL. But that doesn't mean that it's a relational database. It's still a NoSQL database, but it has those capabilities of a SQL database like ACID properties. And then of course it's a fairly large database being used by bunch of like companies, just to kind of point that out. But at the same time, it integrates really well with vector search. So it has integrations with most of the state-of-the-art ML toolings that's existing today, including like LangChain, Llama Index. So that means that you can really build a true Gen AI production-ready applications by integrating it with a bunch of different AI tooling that exists today. And of course, the way that it also stores vector search is that we just launched the functionality just a couple of months back, and now it's right now in beta. So the way that you would basically store your vector embeddings inside of Couchbase is you can just easily store it in that existing JSON format. So if you come from a non-SQL database experience, you're essentially seeing right over here as an example of the JSON storage that you have the type, product ID, category. These are all your default like basic characteristics of a SQL database, non-SQL database, but you're just adding like a new description vector, which is your entire embedding vector. So that's getting stored over here. So just a new field that we're just adding. And as I mentioned that you can also actually make SQL-like queries. So there in that example of the SQL++, you're seeing an example where we are querying data for the product, but we are just adding an additional vector based where we are adding that description vector. And now you're able to actually make your queries. So you based on the input vector, it will find all the nearest vector that exists in your database and give you the relevant results. And of course, since we're talking about edge, right, one of the most important use cases to understand about edge is that as compared to your standard software, right, edge really lacks in terms of compute. So when it comes to like comparing the compute power and the resources, right, especially on edge devices, on IoT devices, a lot of times edge architectures are very resource constrained, right? You cannot just run your traditional GPU or your CPUs on edge devices or even on mobile. Now, yes, while we have made a lot of progress in terms of mobile devices supporting like 10 GB of RAM, 18 GB of RAM, there are still a lot of IoT devices that cannot really run full-fledged applications. So you're normally looking at trying to run applications that are, of course, much more optimized. And similarly, like AI models are also today being quantized so that they can run efficiently on edge. And that's why we'll look at how like Couchbase kind of works on mobile devices. So just to kind of understand the Couchbase mobile stack. So of course, what we covered earlier was that Couchbase as a standalone database comes in a couple of flavors. One is this Couchbase Server and Couchbase Capella, which is a DBaaS, which is a database as a service. Now, those are, of course, for full-fledged applications that are running on server, right? But when it comes to specifically looking at mobile devices, we have something known as Couchbase Lite, which is a fully featured NoSQL embedded database that runs locally in your IoT device or in your mobile. So that runs completely locally. So even if you don't have access to internet, you can still actually run that embedded database. It's basically built on top of SQLite. So if you have worked with SQLite, it's just a flavor, but of course with the features of being able to run locally and in a privacy focused manner. So what today's demo that I'll be showing you is basically going to be a sample app that I built on top of Couchbase Lite. That means that you can actually run that locally on your device. It's a standalone database that will run, and you can actually embed your vectors, or you can actually store your vector embeddings directly inside of Couchbase Lite as well. But of course, if you're wondering that how can we now sync that data back to a main database, so that's also supported with the help of something known as Sync Gateway. that will help you to sync all of the data that's there inside of this standalone Couchbase Lite database with your main database as well. So if you are like, let's say in an area where there's low latency or you have no internet access, you can still store your data and keep your data persistent, and then always resync that data once you gain internet connectivity again. So of course, as I mentioned, that what are some of the advantages to basically run vector search, not just with Couchbase Lite in general, but on edge, right? Because we're seeing vector search coming in large enterprises today. But why should you actually even care to run vector search on edge? So as I mentioned, that the first thing was you can actually run this locally on device, and there are two main benefits, right? And that's what I'd like to kind of talk through these main 3 points. So the first one is, as I mentioned, that for being able to run your vector search on device, that would mean that you need to make special capabilities to actually run that locally, because of course you are normally working in a very resource constrained environment on edge or on mobile. That means that a lot of times as business requirements, you might want to run AI models that can run in a privacy manner. You don't want to send your really important data to a cloud provider like OpenAI. So if you want to run everything locally on device, you can actually do that by running vector search locally. That means all of the embeddings that get generated and whatever querying that you're doing, you can do that in a very privacy focused manner without having to send your data anywhere else. And that automatically means that you're also having lower latency, because now of course you're not having to make an API call to a remote server. You can do all of this directly on device. And of course you can also then do it in an offline mode. That means you don't need to be connected actively to the internet, right? And all of this, of course, as I mentioned, data privacy is a huge factor, because today, like as you might not know, that if you're not using an enterprise version of OpenAI, that means all of the data that you actually send to ChatGPT or you use the GPT-4 API, all of that is actually being used by OpenAI to further train and further fine tune the large language models. So if you're in that kind of scenario where you don't want to send your data to a system, you can do all of that querying locally on device. And of course, you can very easily, if the cases where for some of the queries you might require you to run larger models, because of course, like one of the constraints that we have with edge applications is that you cannot really run very large models on mobile. So if you have this kind of a hybrid application where there are some use cases that can actually leverage some of the smaller lower compute models, you can do that offline. But of course, you can still leverage your cloud-based models for some of the more applications that are more compute intensive, right? So you can very easily do that and still not be worried about having to, be thoughtful of the persistence of data, because that will be managed. And specifically when it comes to with Couchbase Lite, as we mentioned in the earlier example, that with the help of that real-time sync, you can very easily sync between your cloud database and your local database as well. So you can really, run true hybrid applications, whether it's with running your on-device models or being able to make queries to your cloud models. And here's like a sample architecture before I move into the actual demo. So here's a sample architecture of what I'll be showing you. So the idea over here is that I first took a bunch of different images and I just ran through an embedding model. So in today's demonstration, what I'll be showing you is an example of AlexNet. AlexNet is an open source model that allows you to create, it will take an input image and generate a 3-dimensional vector. So that's the 3-dimensional image vector that we'll be storing. And I did that for a couple of different categories. One category is of like Lego characters, and the other category that I choose for today's demo is like shapes, like triangle or circle. So the idea is that first I took these two distinct categories of images. I trained them over in my like using the embedding models. I generated these embeddings, and then I basically store them inside of the Couchbase Lite, right? And then what I'll do is, now when it comes to actually making a search, I will take a new image and I'll again run it by my embedding model that will generate those input embeddings. And now I'll basically run my vector search. So I have my input vector, that's the image that I want to classify. that, okay, does it belong to the Lego characters category or does it belong to the shapes category? And using the vector search, it will find the most similar vectors that exist in my database that are getting stored in Couchbase, and then it will find the most nearest ones that are there, and it will give me those as results. And whichever is the nearest one, that will be the default category that I'll basically make a prediction. So it will basically find the similar media, similar images, and it will give you an output. So basically what I did was I went ahead and created a quiz app, and I'll quickly show you as well. I hope everyone is able to probably see the code. Is everyone able to read it from far behind, or should I perhaps just try to let's see if I'm able to zoom in a bit more. Let's see, increase font size. Okay, let me just go ahead and increase font size a bit more. Is it visible now to everyone at the back? Okay, I'll have to see, okay, like the light mode. Let's see if I'm able to get, yeah, I might have to just quickly check how I'm able to change the, let's see. I might just want to, but I hope everyone is able to see at the back, right? It's fine. Okay. Oh, yeah, I might have to check how to change the theme, but anyways, appearance, perfect. I think I should be able to change the appearance over here. Let's see. Yeah, I might have to take a look in later, but yeah. Anyways, so the main thing that we are doing over here is, and by the way, like the source code will be on GitHub. I'll also share that at the end of the presentation. But essentially, what I'm doing is that first thing that I'm doing is I'm importing a bunch of different libraries which are for Couchbase Lite, and I just first start by creating a default database with the collection and the indexes that I have, and on initial load of my database, so this particular function which is basically used to initialize my database, I am just importing all the necessary collections. So I've basically built a quiz app, and what the app will do is that based on the image that you upload, it will of course use the vector search to find what category of image have I uploaded, and it will basically generate a new quiz based on the category of the image. So just imagine that you're building a quiz app where you upload an image of the Taj Mahal, and it basically generates automatically a quiz on monuments. So imagine that that's where the vector search basically comes into picture, that you're uploading an image of something, and based on the vector similarity, you get what's there in the actual image, right? You're able to do semantic multimodal search. So it's not just like the text-based search, but we are doing it on top of an image. So I basically have like different collection for the user, for the actual questions, and then the score finally that I'll have. And what I do is that on the initial load of my database, I have basically generated the input embeddings. So these are the embeddings where you see the name of the image, then what is the category, so whether it belong, like which particular category does it belong to, and the input vectors that are there. So what I'm doing on the initial load of my database, I'm just storing all these image embeddings inside of my Couchbase database, which, as I showed you as an example, and I can quickly walk you through that once again, which is basically getting stored in this format where you see the description vector. So just imagine that your the way that it's getting stored inside of Couchbase as well is that you're storing that vector inside of Couchbase, right? So that's what is basically happening by initially running that entire app. But this will just happen during the initial load of the application. So where I've just imported this JSON that has all of my input embeddings that are the pre-trained embeddings that I'm storing in my database. So once I basically do that, now I have a separate function, which is essentially the major function, which is the search function, where you can see that I've run a SQL query. So the idea is that when now I upload a new image and I select an image, it will use the embedding model, so the AlexNet model, to generate my new input embedding, and then I'm basically just passing that inside of my vector, so that input vector, and then using the similarity search, it will find the most nearest vectors that are there in my Couchbase vector database and give you the results based on the similarity, right? So just to also quickly show you how that particular input vector also looks like. So this is the actual file that I have, and I'll just quickly open this up with probably with just quickly showing you how this particular file looks like. So this is the actual model itself that I'm running. So you can see like this is the image embedding class, which basically by using the AlexNet model, it's converting your input image into that 3-dimensional vector. And I'm simply just using this get embedding route. So when I upload an image, this is the endpoint that gets called and basically returns that new input embedding vector for the image that you upload. So that's what I'm basically using, and then passing that inside of this SQL query that I'm running, so that it basically finds me those relevant images that are similar to the input image that I've uploaded, and it will return me the category of the image that is the most nearest to the image that I've uploaded. So I'll in my demo application, I'll just give a name. So I'll give my name of Shivay, and I'll click on start. Now it asks me to basically upload an image. So let's say that I first go ahead and select an image. So let's say I take one of these images of the Lego character, and what I'll also do is I'll just open the log over here just to kind of show you that as soon as I select an image, it will basically not only generate the embeddings for that, and then it will do that similarity search from vector search powered by Couchbase. So if I select over here, or perhaps we can also take some other image as well. Probably let's say I take image over here. Let's say if I take this triangle image over here. So now what you see is that as soon as I selected this image of a triangle, what it basically gave us as the result was that of a shape. So if you take a look at the logs over here, what we saw was that first it generated the embeddings for this image, and then it ran the similarity where now it's basically finding the most relevant images from our vector embedding, and it basically said that this is it detected that the category of this particular image is that of a shape. So if I now basically what I'll do is if I start my quiz, it's generating a quiz based on the category that it detected from the vector search. And now, for example, I can just select the different categories. So it's a simple sample quiz app, and I can proceed further and take part in this quiz. And I'll go to the next question. And so basically, once I finish, what you'll see is that once I view the score, it basically has now generated a new leaderboard based on the shapes category. So now let's say if you had multiple categories, you upload an image. So let's say if I had 4 different categories like monuments, food items, animals, and finally let's say something like some other item. So now if I upload an image of let's say Taj Mahal, it will determine that the category is that of a monument, and it will then render a new quiz based on let's say the category of that of Taj Mahal. So that's a quick demo of what we basically covered with with that particular demo. And of course, if you are interested, you can feel free to grab the slides. The code base has been shared, so you can scan this QR code if you are interested in looking and exploring the code base further. And of course, apart from this, what I'll also recommend is beyond vector search, you can truly enable something called as hybrid search. That means basically combining the functionality of both vector search as well as your and full text search together, right? And so you can upload an image of car and probably provide some additional text with it, so that you can get something known as hybrid search. So you get more personalized search results by using both at the same time. And so some of the key takeaways that we saw were that with vector search, you're able to not only do text search, you can also do image search, and of course you can use vector search for generative AI applications and doing things like retrieval augmented generation. And then of course, when it comes to Couchbase, you can do all of that and build Gen AI applications that expand from a server all the way to the edge. So with that, I'll conclude. If you have any questions, there's a booth for Couchbase that's on number 26 booth, and there are we are running quizzes and sponsoring the breakfast. So if you want some cool swag, feel free to drop by our booth. And yeah, if you want to probably take the picture of the QR code, you can feel free to do so. Thank you so much.